Next-Generation Security, Platform and Architecture. In this module, we will discuss an overview of the security platform, next-generation firewall architecture, Zero Trust security model, public cloud security, and firewall offerings. Security Platform Overview. Security Platform Overview. The cyber attack lifecycle is a sequence of events that an attacker goes through to successfully infiltrate a network and exfiltrate data from it. The good news is that blocking just one stage in this lifecycle is all that is needed to protect a company's network from attack. This cyber attack lifecycle model illustrates how Palo Alto Networks views each stage in the lifecycle. 1. Reconnaissance. Just like burglars and thieves, attackers carefully plan their attacks. They research, identify, and select targets, oftentimes using phishing tactics or extracting public information from an employee's LinkedIn profile or corporate websites. These criminals also scan for network vulnerabilities and services or applications they can exploit. 2. Weaponization and delivery. Next, the attackers determine which methods to use. They may choose to embed intruder code within seemingly innocuous files like a PDF or Word document or email message. Or for highly targeted attacks, attackers may craft deliverables to catch specific interests of an individual. 3. Exploitation. Once attackers gain access inside an organization, they can activate attack code on the victim's host and ultimately take control of the target machine. 4. Installation. Attackers will seek to establish privileged operations, a rootkit, escalate privileges, and to establish persistence. 5. Command and control. Attackers establish a command channel back through the internet to a specific server, so they can communicate and pass data back and forth between infected devices and their server. 6. Act on the objective. Attackers may have many different motivations for attack, and it's not always for profit. Their reasons could be data exfiltration, destruction of critical infrastructure, to deface web property, to create fear, or to extort. The Palo Alto Networks platform is a prevention-focused architecture that provides visibility into all traffic, is natively integrated in such a way that no gaps exist, and context is delivered so you only have to react to threats that are critically important. It is highly automated to reduce or remove manual response and enables you to drive seamless policy throughout your organization to reduce your attack surface and eliminate unnecessary risk. The platform safely enables all applications through granular use of controls and prevention of known and unknown cyber threats for all users on any device across any network. NGFW. Palo Alto Networks' next-generation firewalls are designed to safely enable applications and prevent modern threats. The Palo Alto Networks approach identifies all network traffic based on applications, users, content, and devices, and lets you express your business policies in the form of easy-to-understand security rules. Threat Intelligence Cloud. The Threat Intelligence Cloud correlates global, community-driven threat intelligence from multiple sources across networks, endpoints, and clouds to immediately halt threats from spreading. Advanced Endpoint. Traps Advanced Endpoint Protection provides multi-method prevention, a proprietary combination of malware and exploit prevention methods that preemptively block both known and unknown threats directly on an endpoint.
What is that?
Where?
You see this way?
Facebook comments plugin.
And you have your photo. When you finish your Facebook, log out.
Okay.
When you finish the Hotmail, log out. Because I am using log out. Where is sign up? Jesus Christ, this place is...
Where the yeah. Notification. No. Click. Home.
Panorama. Panorama Network Security Management provides consolidated policy creation and centralized management. It allows for the setup and control of firewalls centrally with an efficient rule base and adds insight into network-wide traffic and threats. Autofocus. Autofocus is a hosted security service. It's part of the Threat Intelligence Cloud. Autofocus gives security operations and analysis teams direct access to all the threat intelligence Palo Alto Networks gathers from customers, open source feeds, and the Unit 42 Threat Research Team. Security teams can then focus their efforts on the most important attacks and understand the most critical elements of those attacks via the globally correlated analysis. Aperture. Aperture Service protects cloud-based applications such as Box, Salesforce, and Dropbox by managing permissions and scanning files for external exposure and sensitive information. Aperture is focused on data loss prevention, or DLP, for personally identifiable information, or PII, and payment card industry, or PCI, information, as well as other sensitive data. Global Protect. Global Protect network security for endpoints safeguards the mobile workforce by inspecting all traffic using the organization's next-generation firewalls that are deployed as Internet gateways, whether at the perimeter, in the DMZ, or in the cloud. Laptops, smartphones, and tablets with the Global Protect app automatically establish a secure SSL IPsec VPN connection to the next-generation firewall with the best performance for a given location, thus providing the organization with full visibility of all network traffic for applications and across all ports and protocols. The organization that eliminates the blind spots in mobile workforce traffic maintains a consistent view into applications. Next-generation firewall architecture. The Palo Alto Networks firewall allows you to specify security policy rules based on a more accurate identification of each application seeking access to your network. It is unlike traditional firewalls that identify applications only by protocol and port number. It uses packet inspection and a library of application signatures to distinguish between applications that have the same protocol and port and to identify potentially malicious applications that use non-standard ports. The strength of the Palo Alto Networks firewall is its single-pass parallel processing, or SP3, engine. Each current protection feature in the device, antivirus, spyware, data filtering, and vulnerability protection, use the same stream-based signature format. As a result, the SP3 engine can search for all of these risks simultaneously. The advantage of providing a stream-based engine is that the traffic is scanned as it crosses the box with a minimal amount of buffering. This speed allows you to turn on advanced features such as scanning for viruses and malware without slowing the firewall's performance. Palo Alto Networks offers processors dedicated to specific security functions that work in parallel. These components can be implemented in hardware or software. On the higher-end hardware models, the data plane contains 3 types of processors that are connected by high-speed 1 gigabit per second buses. Signature Match Processor scans traffic and detects vulnerability exploits, intrusion prevention system, viruses, spyware, credit card numbers, and social security numbers. Security processors, multi-core processors that handle security tasks such as secure socket layer decryption. Network processor, responsible for routing, network address translation, and network layer communication. On the higher-end hardware models, the control plane has its own dual-core processor, RAM, and hard drive. This processor is responsible for tasks such as management UI, logging, and route updates. Zero Trust Security Model. The constant cyber attacks against organizations show that perimeter security strategies alone are not effective. Without true visibility, IT and network security teams cannot control the users and applications traversing the network. Limited visibility results in organizations being vulnerable to attacks from both within the organization and from the public internet. In the majority of breaches, hackers first infiltrated an end-user device before moving into the data center. Traffic protection from external locations, where the egress point is the perimeter, is commonly referred to as north-south traffic. Protection also is needed for traffic within the network, because that's where the malicious lateral movement techniques will take place. This traffic is referred to as east-west traffic. The primary issue with perimeter security at both the ingress and egress points on the network is the false assumption that the internal traffic taking place within the internal network can be trusted. Vulnerabilities include the following situations. Remote employees and mobile users are treated as internal traffic. Wireless users, partner connections, or guest users introduce new ingress points into the network. Remote offices may need to be considered as providers of untrusted traffic because of where they are located, regions of instability or rogue nations or countries. And internal employees unintentionally present a security threat. USB keys, file downloads, and transfers. Zero Trust is an alternative security model that addresses the shortcomings of failing perimeter-centric strategies by removing the assumption of trust. With Zero Trust, there is no default trust for any entity, including users, devices, applications, and packets, regardless of what it is and its location on or relative to the corporate network. Zero Trust is a promising alternative model for IT security to follow. It is intended to remedy the deficiencies with perimeter-centric strategies and the legacy devices and technologies used to implement them by promoting never trust, always verify as a guiding principle. This approach differs substantially from conventional security models that operate on the basis of trust but verify. The implications for these two changes are, respectively, the need to establish trust boundaries that effectively compartmentalize different segments of the internal computing environment. The general idea is to move security functionality closer to the different pockets of resources that require protection. This way, security policy can be enforced regardless of the point of origin and the communications traffic associated. Trust boundaries need to do more than just provide initial authorization and access controls of enforcement. To always verify also requires the continuous monitoring and inspection of the associated communications traffic in search of subversive activities. Palo Alto Networks' next-generation firewalls offer a range of threat prevention functionalities that together offer an integrated approach against prevalent threats. Threat prevention capabilities of the Palo Alto Networks' next-generation firewall include the following: application identification, user identification, URL filtering, vulnerability protection, anti-spyware, antivirus, traps, file blocking, DOS protection, zone protection, and wildfire advanced malware protection. Each function protects against specific types of threats and is configured in the zone settings and the security profiles, and then is applied to the various rules of the security policy. This integrated protection will safeguard against threats and also provide application visibility and control over the network. Public cloud security. Cloud deployments have additional security challenges to overcome compared to traditional deployments. Traffic visibility is more limited. The built-in security tools are outdated and/or inconsistent. And process management is cumbersome. Note: SaaS security is achieved with Aperture.
Hello everyone, my name is Warby Warburton. I'm a tech marketing engineer at Palo Alto Networks, and today I want to continue our conversation on how to secure the data center, specifically around how to leverage the flexibility and availability of the public cloud without sacrificing our security that we've already built in our own data center. I'm going to begin by drawing where we left off previously with our private data center and then add on public cloud resources, extending our existing security into the cloud. Okay, now we have the data center where we left off in the last set of videos. In this case, I have a colo that's connected remotely to my headquarters location using VPN tunnels. And I've got a 3-tiered application structure with app, web, and database servers. And I've got virtual firewalls protecting the traffic between the application tiers and physical firewalls protecting the traffic in and out of the data center. Next, I want to talk about some of the use cases for using public cloud. For example, if your compute varies widely during different times of the year, maybe fiscal year processing, or you're an online retailer and you have big spikes of usage during the Christmas season, rather than invest in hardware that sits unused for most of the year in your data center, you can expand and burst into the public cloud and use that temporary resource. Another example is you may have a project that's temporary where you need to do test and development work. Again, it's not a year-round effort. You don't want to have permanent hardware investment, so use the public cloud, and you can quickly scale up for that project and just tear it down when the project is done. Additionally, the public cloud has a global presence, which is very advantageous for things like a global remote access solution like our Global Protect. Okay, so now I'm going to draw our public cloud, and as an example, we'll have 2 availability zones. And in my case, let's say my database tier is quite busy and I need to ramp up to handle additional processing. So I'm going to deploy additional database servers into the public cloud. And I'm going to put them in different availability zones for maximum redundancy. But I don't want to simply put this resource in the cloud and not have the same security enforcement that I had in my private data center. So I'm going to deploy virtual firewalls in this location as well. Now what I can do is I can connect these virtual firewalls into my existing infrastructure and I can manage it from a central point. So I'm going to do the same kind of VPNs I did to connect my corporate site, and my Panorama instance at the data center can still manage these firewalls. These firewalls will actually be in a different device group so that I can do unique policy specific for the cloud. but it'll be the same panorama. I can share objects, things like dynamic address groups. So for example, a new database server spins up. I can learn about that dynamically, both in the cloud and my physical firewalls at the private data center. The other advantage to this solution is I don't have to sacrifice on the policy here. I can do things like user ID, so a remote IT resource can still connect in and do things like RDP and SSH, but other users at headquarters or out in your customer space would not have the same application access. I still can use App ID, so I can limit the traffic, for example, from this web server to this database server to just MS SQL, for example. In addition to App ID and User ID, I also want to have all my threat protection for both known and unknown threats. Things like wildfire absolutely make sense in this environment. And I can use a combination of the Amazon AWS API and the PAN-OS API in the firewall to automate many of the tasks in this environment, so I can quickly spin up and spin down resources and secure those, including the firewall itself can be spun up automatically. So we now have an environment where we have central management and logging with Panorama. We can manage all of our firewalls in different device groups, but with common elements like dynamic address groups. We can scale up and scale down very quickly. We can burst things like a database tier into the AWS public cloud and scale it back down when it's not needed without any permanent investment in hardware. And we don't have to sacrifice any security. All of the next generation security features at our private data center are available in the public cloud. For more information about how we secure public and private clouds, please go to our website, www.paloaltonetworks.com.
Firewall offerings. The PA220, PA800, and PA5200 series are next-generation hardware, released with PAN-OS 8.0. The PA7050 and 7080 are chassis architecture. The operating system is consistent across all platforms, so the look and feel of the interface is the same. To compare the capabilities of the various firewall models, refer to the following site. As of PAN-OS 8.0, the VM series firewalls now support a wider range of deployment scenarios and higher volumes of traffic when compared to previous versions of PAN-OS software. These enhancements enable three broad use cases: optimized resources for customer premise equipment, or CPE, and network tenant environments, improved performance and efficiency for perimeter and east-west data center traffic, and maximized performance to support network function virtualization, or NFV. All VM series firewalls use a unified licensing system, which is platform agnostic. For example, a VM100 perpetual license can be used to license a VM running on Hyper-V or in AWS. This table shows the supported environments and the VM series models capabilities. VMware ESXi, all. KVM OpenStack, all. Hyper-V, all. VMware NSX, VM100 through 500. AWS, VM100 through 700. Microsoft Azure, VM100 through 700. New sessions per second, all models, 8,000. IPsec VPN throughput, all models, 250 megabytes per second.
Let's take a few minutes and talk about the flow logic for the Palo Alto Networks next generation firewall. Okay, let's say that a user from the internet wants to get to our company web server in the DMZ. We are going to go through our flow logic to see how it passes through the firewall to the web server. The important thing to remember before we get started is that this is a general overview of the flow logic. While it is presented in a serial process, all of the packet processing is actually performed in parallel in a single pass through the firewall. Let's begin. When the packet enters the firewall, we know 5 pieces of information that we are going to refer to as the 5 tuples. We know the source IP, source port, destination IP, destination port, and the protocol. In the first step, we're going to determine the source zone based off of the source address. If you look at the diagram, the source IP 152.18.45.1 is on the untrust side of the firewall. Now if it's coming from say 192.168.10.50, we could also have tagged the information with trust and Tiny Tim. But in our example, it's coming from 152.18.45.1. So the firewall is going to tag that packet with the source zone is untrust. In step 2, we are going to look at our policy-based forwarding rules. If we have a match, we would jump from this step to step 15 and forward the packet appropriately. No security processing would be done. Instead, wherever we forwarded the packet to, that device would be responsible for doing the security processing. Since we didn't have any policy-based forwarding rules that matched, we move on to step 3, where we look at the destination IP, which in this case is the IP address of our untrust interface, and label the packet with the destination zone as untrust. In step 4, we would look at our NAT policies and notice that if we have traffic coming from untrust to untrust on port 80, then we are going to forward that packet to 1030.1180, which means ultimately the destination is going to be the DMZ. So the firewall will mark out untrust and make it DMZ. Notice the firewall did not change the destination IP. We only evaluated the NAT policy. We did not apply it. In the next step, the firewall will look through all of the security policies on the system and see if the destination port is allowed by any of them. If it is, we will move on to the next step and create the session. Next, we will check to see if the traffic is encrypted. This is important to determine whether we can do actual application ID. Many applications today tunnel other applications or information through encrypted applications. That is why the next step, decryption policy, is so important. Here we will attempt to decrypt the encrypted packet if we have a policy that allows us to do so. This will ultimately allow us to accurately examine the packet in later steps. In the next step, we will see if we have an application override policy. This policy basically says if it is coming from this server on this port, then it is this application. So skip to the last step and forward the packet out the appropriate interface. We won't do any security processing on this packet. This is a temporary solution for, say, an in-house application that may be being misidentified in the App ID process. If there is no app override, then we will attempt to identify the application in this step. In this case, web browsing would be the application, and we would look and see what kind of content inspection can be performed on this application, i.e. virus checking, file blocking, and data filtering. Next, the firewall will check its security policies and see if web browsing is allowed. Since it is, we will move on to the next step. Now we have a look and see if there are any security profiles attached to the security policy that allowed web browsing. If there are, then we will scan the packet for viruses, data filtering, URL filtering, and so forth. If the packet is clean, then we proceed to the next step. It is important to remember that we only do virus scanning and other profiles on packets that are allowed by a security policy. Now, if we decrypted the packet, we will re-encrypt it here. If we don't re-encrypt it, then it could break the application at the other end. In other words, if a web browser requested HTTPS traffic and then all of a sudden got unencrypted traffic, it would drop the session. So it's very important that if we decrypted it, we re-encrypt it. Now we apply the NAT policy, and we actually change the IP address in the packet header at this point. Then the firewall will forward the packet to the appropriate interface and send it on its way. That's it. That is the flow logic. For more detailed information, you can go to www.paloaltonetworks.com and search for a document called A Day in the Life of a Packet. This is a very technical, in-depth explanation of how the packets are processed through the firewall. This, however, gives you a good general understanding of how the firewall works. Thanks for listening.